Hello, lovely math mavens. Today I'm going to be doing a quick little video for the example found in number 3. I'm going to be talking about a sampling distribution for a proportion this time instead of a mean. And it looks like you can't quite see the top of my mini tab. Uh-oh. Can I make this bigger? Hold on for a second. Okay, fix the problem. Now we're good. That sounded weird. Anyway, so suppose we're going to look at a survey that's conducted from a population of people of whom 35% have purchased a new computer in the last year. And we have this following sample that they gathered, and they asked the same question, hey, have you purchased a new computer in the last year? What we're first going to do is calculate the sample proportion of people who responded that yes, they have purchased a new computer in the last year. So in particular, that tells us that we're looking for a p bar because it's based on a sample. Sorry, mine look a little weird. And then if we go through and count, let's see, there's 3 columns and 1, 2, 3, 4, 6, 7, 8, 9, 10 rows. That tells me there's 30, because it's 10 3 times. Doo-doo. And then of those 30, how many said yes? Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's going to be easy. So 10 out of 30 are 1/3. So we're going to have to round this because it's going to be 0.3 repeating. So I'm going to do what I usually do, is just use 4 decimal places. Oops. Hit undo a bunch because I'm about to write something that's not true. It's not equal. I'm approximating here, so it's not perfect. I'm going to use approximately 0.333. My 3's look dumb. Oh well. You get the point. Anyway, so we're going to look using this scenario with this sample proportion and this population proportion at how many, or what's the probability that we get. I wanted to put this on the next page. Using the amounts in part a population that has having 33% purchased a new computer in the last year or more. Okay, so I want to look at, I'm sorry, my phone's going off. I want to look at the probability that the proportion is greater than 30. When observed, the value in part A, oh yeah, this one, so 0.333. If, ooh, that 3. Why do I even try writing with a pen? It looks kind of bad. It feels more like I'm doing it with you, right? Like I'm writing alongside. Anyway, so this is what I'm going to be looking for, the probability that my sample is 0.3333 or greater. So this is based on using the population proportion right here. So that's what I'm going to use to build my distribution. So we're always going to use something about the population to try to build our distribution and then move from there. So that tells me that in particular when I'm looking for the mean of the sampling distribution of proportions, my mean is always the population proportion. That's supposed to be a 0. So that's going to be 35% because that's what I have that I'm basing this on. And then my standard deviation of the population proportion, that's always the square root of p1 minus p. I'm writing out the formula so you remember it before I do it. Oops, I didn't need the bar there since I'm just using the regular one over n. I'm going to have to calculate that because I don't know what that's going to be. So it's going to be the square root of 0.35. That looks weird. I'm going to do 1 minus 0.35 real quick so that looks better. It was 0.65. I had a feeling that's what it was, but not a feeling. I was calculating it in my head, but it's nice to confirm it. Extend my root a little bit. And then my sample had 30 people. There's a lot of 3's in this one, so you got to be careful. All right, let's calculate this and see what it is. So I got 65 times 0.35 divided by 30 equals, it's pretty tiny. Let's take the square root. The square root button on the Microsoft calculator looks weird to me. I don't know if you guys feel the same. So we get 0.087, and I like 4 places, so I'm going to do one more and get a 1 there. Alright, so now I need to calculate the probability. So I'm going to use Minitab to do that. I know that this is going to look relatively normal because it's a pretty, well, actually I should check that. Do I have at least 10 successes? Yes, because that was my numerator up above. So if these are my successes, my people that said yes, the number of people that didn't say yes was 20. So that's both bigger than 5. So since 10, which is n times p, is greater than 5, and 20 is also greater than or equal to 5. I know this is going to look normal, so now I can actually do this. I should always check that just to be safe. Okay, so I'm going to calculate my probability. View probability. It is going to be normal. I had to check that first. Now my mean is going to be 0.35. My standard deviation is 0.0871. And I'm going to do shaded area. I'm going to input this proportion, which is a value, not a probability. Be careful. And that's 0.33, and I want greater than, so that's going to be right tail. Hope this isn't too fast for you. All right. Remember, you can always slow down YouTube videos too, which is nice. So as you look at this, hey, it looks like I'm doing this right. So let's see, right, because it's greater than 0.333. All right, let's hit OK. Oh, that's pretty big. Well, it was pretty close to the mean based on the standard deviation. Oh, this is a problem. So in Minitab, if it gets too close like this, you can pick these numbers up. Oops. Click and hold to move them over. So 0.33 is right next to the mean. The mean is at the center, right at the peak. And then 0.333 is where this value starts. So it looks like my probability is going to be 0.5760. So this is my answer. All right. So that's how you can calculate a probability based on a given sample using a proportion. So in particular, notice that this type of data where I've got answers or responses that are non-numerical, this is going to be qualitative, and therefore I'm going to have to do proportions with it. So it's important for you to notice the variable type when you're doing these so you know which type of distribution you're going to be doing and which mean you're doing. And don't forget, like, you have a totally different standard deviation when you are using proportions and not using means. That highlighting looks horrible. Why did I do that? This thing is different. Anyway, thank you for watching.